Hello everyone, welcome to JavaCharter. In this video, we are going to cover a J.P. Morgan interview questions and answers. Wishing everyone a heartfelt Ugadi greetings, Happy Ugadi to all, and Happy Ramadan Kareem to all Muslims. I want to convey an important message here. Last time when I uploaded the JP Morgan interview questions and answers, many people commented that those questions were for the freshers or junior level candidates. Well, I want to clarify that those questions were the same ones which I faced during my own interview process. I did not fabricate any questions myself. They were real interview questions which I faced during my interview. And the questions in this video were faced by my friend who had over 7 years of experience when he appeared for the interview. He is currently working at JP Morgan in Mumbai. I want to clarify that these questions were shared with me by him currently who is working at JP Morgan. I haven't personally experienced these questions myself, but I am excited to share them with you to provide the insight into the interview process at JP Morgan. This video is just the beginning of a two-part series. Be sure to stay tuned for the part 2 coming soon. Now let's dive in. Question number 1 which my friend faced at JP Morgan was, what is caching and what is a distributed cache system design? So to answer this question, caching is a process of temporarily storing frequently accessed data in faster, closer and easily accessible memory location called cache memory instead of retrieving the same data repeatedly from the slower remote locations such as database. This technique helps improve application performance, reduce data transfer and query latency, and minimize the network traffic by providing the faster access to frequently accessed data. Now, what is distributed cache system design? So, a distributed cache system design is a caching architecture that involves multiple cache instances distributed across a network of interconnected servers. Data is cached locally in the memory of each cache instance to accelerate the data retrieval process and reduce the load on the main server. This design helps improve scalability, reliability, and fault tolerance, as well as optimize the data access performance across geographically regions. Additionally, it enables data redundancy and more efficient use of network resources. The another question was, what are the differences between callable and runnable in Java? This is very common question. So to answer this question, first of all, we will try with the return value. So callable returns a value and can throw an exception, whereas runnable does not return a value and cannot throw an exception. Threading. Callable can be executed directly using a future task object and provides the ability to wait for the result. Whereas runnable on the other hand can only be executed from within a thread object and does not have ability to return a value. Method. Callable has a single method call that needs to be implemented, while runnable has a single method run that needs to be implemented. Exceptions. Callable methods can throw checked exceptions while runnable method cannot throw checked exceptions. Question number 3, how to create a Docker file of a Spring Boot project. And so to create a Docker file of a Spring Boot project, the step 1 is, in the base directory of Spring Boot project, create a Docker file. Step number 2, specify the base image in the Docker file using from command. For example, you can use the OpenJDK image as the base with the specific version number. Step 3, add the project jar file to the Docker image using the add command. For example, add the project.jar and then space myproject.jar. Step 4, expose the port on which the Spring Boot application listens by using the expose command. Step 5, use the cmd command to define the default command to run when the container starts. For example, I have shown a cmd example here. Step number 6, save the Docker file and bin the Docker image using the docker build command. For example, docker build -t and your project -image and the dot. Once the image is built, you can run the container from the image using the docker run command. For example, I have shown here docker run -p, then port number my project image. So here is an example of a Docker file for a Spring Boot project. So you can see the first step is use a base image with Java 8 install. You can see from OpenJDK how I have written, and then set the working directory in the container, copy the Spring Boot application jar file into the container and set the command to run the application. The Docker file starts from the base image with Java 8 installed, sets the working directory in the container to app, copies the Spring Boot application jar from the target directory to the container's app directory, and sets the command to run the application by executing the jar file with the Java command. The build To build the Docker image from this Docker file, save the file to the root directory of your Spring Boot project and run the following command from the terminal in the same directory: docker build -t my Spring Boot image, and then this comes, you can see the dot at the end, right? So this command builds a new Docker image with the tag my Spring Boot image based on the instruction in the Docker file. Note that the last dot specifies that the build context is the current directory. Question number 4, can you explain the Spring Boot core concepts? So to answer these questions, we can say the core concepts are auto configuration, Spring application context, Spring Boot starters, embedded server, Spring Boot actuator, Spring Boot CLI, Spring Boot data. These are just a few of the core concepts of Spring Boot. Overall, Spring Boot aims to simplify the development process by providing a set of opinion-tinted defaults and tools that allows developers to quickly build and deploy production-ready applications. Question number 5, multi-threading use cases. How do we handle huge data and design related questions like how do you design an application? So multi-threading use case, if I want to say, we can say that allow an application to perform multiple operations independently, handle simultaneous user requests in the web applications or any other application. So you can tell any example. If I tell you guys, let's say we are reading the data from various equipment. Let's say if we take the example of railway domain. So in railway there are various equipments connected to railway and the railway systems, from which we need to simultaneously read the data. If there is a trip, we receive the data, we pull the data. So there is this is one of the example of multi-threading use case. Now the question number 2, how do we handle huge data? So we can use the query systems to keep frequently accessed data in the memory for faster access, use indexing and search algorithms to quickly search through the large database, use pagination and filtering mechanisms to limit the amount of data written. These are the few just examples. Now application design related questions, you can tell identify the testing and development strategies, identify the technologies and libraries that would be the best suited for the development. So I would say, like I told about the railway domain example, right? So according to me, the best technology would be the Akka toolkit, Akka framework, and the Scala language. Now question number 6, can you explain how hashmap and concurrent hashmap works? This is again a very common question. So hashmap is a data structure that stores the key value pairs. We all know that, right? It uses the hashing algorithm to find the index of an element in an array called a bucket. The algorithm converts the hash code of the key into the index of the bucket. Here how it works: when a key value pair is added to the hash map, the hash code of the key is used to find the index of the bucket. If the bucket is empty, the key value pair is added to the bucket. If the bucket is not empty, the algorithm checks if the key already exists in the bucket. If it does, the value associated with the key is updated with the new value. If it does not, a new key value pair is added to the bucket. When retrieving a value from the hash map, the hash code of the key is used to find the index of the bucket, and the value associated with the key is returned. Now concurrent hashmap. Concurrent hashmap is a thread-safe version of hashmap. It is designed to provide better performance in a multi-threaded environment. Concurrent hashmap is implemented using a similar approach to hashmap but with some key differences. Here is how it works. Concurrent hashmap divides the entire map into smaller segments or locks, often called the buckets, while trying to avoid locking the whole map. Each segment can be accessed independently. Concurrent hashmap maintains multiple locks while updating the key value pairs. When a value is updated, only the segment lock is obtained, instead of obtaining a lock on the entire map and blocking the other threads. Concurrent hashmap provides a higher degree of concurrency than the hashmap. It ensures thread safety while maintaining a high performance under concurrent read and write operations. Now question number 7, what exactly is a containerization and what are the steps involved in creating the containers? Now, containerization is a process of packaging an application and all its dependency into a single lightweight and portable container. A container is an isolated self-contained execution environment that runs the application software. Containers provide a consistent environment across multiple operating systems and environments, making it easier to develop, test, and deploy applications. Now, steps involved in creating containers. So, choose a containerization platform. There are numerous various containerization platforms available in the market, such as Docker, Kubernetes, Apache Mesos, and LXD. Define the container requirements. Identify the application dependency, language runtimes, and requirements of container. Determine the resource usage, network requirements, and security levels. Write the Docker file and all configuration file. The Docker file contains all the necessary instructions and dependency for creating the container. This may include the base images, application code, libraries, configuration, and port exposed. Build the container image, which I explained in the previous question. Use the containerization platform to build the container image. This involves executing the Docker file or configuration file and creating the container image. Steps involved in creating containers. So the test the container image to ensure that it is working properly and the application runs as expected in the container environments. Push the container image to registry. Store the container image in a container registry where it can share with the others, automatically deployed to a different environments. In summary, containerization is the practice of packaging an application and its dependency into a lightweight and portable container. Question number 8. Write code to invoke a REST service. Use REST templates. This was the question asked. So I have given here one example where I am creating the object of REST template using a new REST template. I'm providing the string URL. Then the HTTP headers, I'm creating the object of that. Now headers dot set accept arrest as list media type application JSON and HTTP entity of type string, where we are adding the require body and response entity. So you can see the example here. This is one of the way. The another example is very simple. So where you are creating a REST template object and then one string URL, and in the string response you are using a REST template dot get for object. You are passing the URL and the string dot class, and then when you print using system dot out dot println response for REST service, you can directly print the string response. So in the last example, we use the get for object, right? So you can see here we have used a get for object REST template dot get for object. So get for object method, which simplifies the process of making GET request, fetching the response as an object of the specified type. This method provides the convenient way to make the simple REST API call without the need of configure any additional settings. Whereas in the first example which I showed, we use the extend method, which provides more flexibility and configurability when making an HTTP request. This method allows you to specify the HTTP headers, request body, and another parameters of the request, and it returns an object that includes the response headers and body. Now question number 9. What sets Pivot Cloud Foundry apart from other cloud service providers such as GCP, Azure, and AWS? So to answer this question, PCF Pivotal Cloud Foundry is a cloud platform that is designed to help organizations deploy and manage their applications across multiple cloud environments. Here are the few key features and capabilities that sets PCF apart from the other cloud providers. So first is multi-cloud supports. One of the key features of PCF is its ability to deploy and manage applications across multiple public and private cloud environments, including AWS, Azure, GCP, and vSphere. Now the another important point is developer productivity. PCS offers a range of tools and features that helps developer to build, deploy applications more quickly and efficiently, including a self-service portal, automated configuration management, and continuous delivery pipeline. The another important point is container management. PCF includes a container management platform that provides automated scaling, self-healing, and load balancing capabilities. This makes it easier to deploy and manage containerized application at scale. Integrated security. PCF includes a range of security features, including a network segmentation, SSL, TLS encryption, and built-in security controls for authentication and authorization. Hybrid cloud capabilities. PCF is designed to enable hybrid cloud deployments, allowing businesses to deploy and manage applications across both on-premise and cloud-based infrastructure. Question number 10. How is Git and Jenkins configured? How does the build job executed when there is any Git push? So to answer this question, the Git and Jenkins integration allows for continuous integration and continuous delivery CI/CD of code changes to an application. So high level explanation here I am telling you guys. Developers make changes to the code and push these changes to the Git repository. The Git repository is set up to trigger an event, for example a webhook. When changes are pushed, Jenkins detects the Git event and automatically triggers a build job based on the content of the repository. Then during the build job, Jenkins pulls the latest code from the Git repository. The build job runs the series of predefined actions based on the content of the code, such as the running tests, compiling code, and creating artifacts. If the build job completes successfully, Jenkins deploys the artifacts to the predefined environment, for example, test or production environment. If the build job fails, Jenkins sends a notification to the developers with the details of the failure so that they can address the issue and push the updated code to the Git repository. The process is known as a continuous integration and continuous delivery, which is called a CI/CD pipeline. Thank you very much, guys. I hope these questions were helpful. I will soon upload the part 2. Till then, bye bye. Take care.